Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Isn't it a great endorsement? I did a presentation last year, and it's great to see so many more people here this year, right? Which I think is a great endorsement for John and his team at JCT, which is really brilliant. Listening to people talking about how long they've been in the industry made me sit there and think about how long I've been in the industry, and it's 30 years. It makes me sound really old, but there you go. So we're going to talk today about a case study, actually. Myself and Bob Roth is my client, actually, from Via East Midlands. We did an installation about a year ago. It was just after JCT last year at a junction in Newark, which had been giving some problems to Via East Midlands, where they had some failing in-carriageway detection, and they made a decision to actually change the technology out there. So Bob is going to talk about the actual technical side, or the decision-making process on that. I'll talk about a little bit about the product that we used, and then Bob will summarise at the end. The junction itself is a busy junction. It's Lincoln Road and Winthorpe Road in Newark. So without further ado, I'll actually hand over to Bob.
All right, thank you, Peter. Thank you. Yes, I think Peter's done half the job there already by describing where the junction is, so I can sit down. Yes, the site itself is just a fairly basic signal crossroads. It's on the east side of Newark, on the old Foss route. There's a more detailed plan of it itself. It's the main road out of Newark to go towards the A1 in the east, so it can get busy, especially with commuter traffic from the town centre itself. And as you can see on there, it runs more or less diagonally from the bottom left-hand corner, the southwest, up to the top right-hand corner. The two side roads, there's Winthorpe Road on the northern approach, and then Northern Road on the southern approach, which can cause a bit of confusion at times. They're both rather busy with domestic traffic. They serve housing. They also serve some industry along both approaches. And as I said, Lincoln Road is the old Foss. It's the old main road. It was bypassed many, many years ago, really. Sort of the A46 runs and loops around to the north. But that can get congested. I know works have been done in the past to improve the congestion, but the savvy driver at certain times of the day will choose to go through the centre, down the old route, adding more to the traffic at this site. So I'd say it is a rather busy site, and as you can see, the ADT on that is 18,300 vehicles. So that's how many vehicles go through there two-way per day. A quick history of what we've done there. The site was set up or first installed in 1972, so it's its 50th birthday. And like many, many sites, it's had small improvements, maintenance improvements, upgrades over the years. There's just a few highlights there. Sort of 2006, we went for an 800 controller. 2012, because of the business of the site, we finally managed to put a case together to put MOVA on there to manage the capacity, and as Dan was saying, to try and smooth out the shoulders of the peak and say manage what capacity we have in the site more efficiently. In November 2016, the junction was finally redesigned and it finally got pedestrian facilities. So it managed at this really busy site without them up to that point, and that was as part of a cycle upgrade scheme along the whole Lincoln Road route. And in October 2021, the MOVA detection really was coming to the end of its useful life, and we needed to upgrade the system to something which hopefully would take us on into the next few years. Now, going back to the decision in 2012, when we put the site onto MOVA, Obviously, we wanted to get the benefits of MOVA, and we wanted to go for a wireless system. The reason being, and it wasn't shown quite on the overhead plan, just about 100 metres to the west of the site is the East Coast Main Line with overhead line equipment at 25 kilovolts. And the Lincoln Road, doing a conventional MOVA installation, we're going to have in loops around about 100 metres in advance of the stop line, which put them plumb onto that bridge. We were reluctant to have to deal with third parties, because say it's not our bridge. We were reluctant to do civils works in a structure, just in case there was going to be any issues with damage to that. And also, we were very reluctant to go anywhere near that wiring. Firstly, from just a road workers' safety point of view, but also if there are any issues with radio frequency interference from either the lines or from the network rail comms, we didn't want that to be affecting our site. So we were very fortunate at the time that just coming onto the market was the magnetometer system, which we thought would be perfect for that. There was no need to do any ducting, so it was supposed to learn sort of the electromagnetic environment around it and tune out interference. So we went with the magnetometers. The experience has been mixed. The big advantage, obviously, they saved us an awful lot of time and money in not having to dig up the road to put them in. And, excuse me, I'll just carry on. I don't quite know what's happened there. It's restarting itself. But whilst we have this brief intermission, yes, we started to run into issues with reliable service from the magnetometers, especially as the years went by. We had certain issues with repeaters going down. Now, being a local authority, which was strapped for cash, or local authority at the time, we went for the cheapest option for the repeater batteries of 2 years, knowing that we would have to instigate a program for annual or biannual renewal, which so we went into with eyes open and we carried that out. But I think one of the problems which we then ran into was with the battery life of the studs, especially as they started to approach the end of their life. They were expected to be, I think, 8 years at the time, and we started to run into reliability problems with those. So we were frequently getting issues with studs going down, approaches not having detection, or approaches being PD'd. So as they were coming to the end of their life and seeing actually just, it was an irony, we're seeing the date we put it in, and it's actually 10 years ago since we put the magnetometers in. We have obviously reached the end of that practical life, so renewal wasn't necessary. So the thought was, what can we do next? We wanted to go for overhead detection again, just to keep clear of the bridge issues. And our normal method would be AGD 318, which we've used to great success so far on many single-lane MOVA sites, crossroads and crossings, and they have been really, really successful. But the one fallback with them is they are single lanes. And obviously here, or as you would see if it were there, we have 2 lanes on each approach, which means multiple detectors and also problems with spread and difficulties aiming the detectors, especially over a long distance. So we started scanning around for other information and other detection systems and came across the SVS smartmicro, which seems to offer the advantages of the AGD system, but with the big benefit of being multi-lane. So they have 8 outputs. We could do one detector would do a whole approach. And so we got into conversation with SVS and throughout the summer of 2021, built up a scheme which, as Peter was saying, was installed in October 2021. And I'll hand back to Peter with the technical stuff.
I thought I was going to have to do a dog and pony show there. Well,
there we go.
Thank you. Okay, our choice of detector for this particular application is the UMRR11, and it's the UMRR11 Type 45 radar, Type 45, which actually refers to the type of antenna. I'm going to read all the stuff that's up there, you can read it yourself, but enough to say that this particular radar is the one most commonly used in the urban environment today. Rather shocked I was today when I found out that we sold about 300 of them in the last just under 2 years, so it's quite a popular product. And I'm going to preempt here a question that I know I'm going to get from Mark Pladell later on. Are you going for Topaz? And the answer is, yes, we're in the process of doing that right now. So, sorry, Mark. These are the different antennas, antenna types for the UMRR11. The one on the left is Type 44, which covers up to 6 lanes. The one with the arrow pointing at it is the one we actually use, which is the Type 45. It's 4 lanes and out to 219 meters. And then the two on the far right there are the UMRR11 Type 132, which is a 77 gig unit. And that has a medium speed, a medium range and a long range detection in it within the one product. So those are the wave patterns from those, so the detection patterns from that particular radar. At the bottom there, quite an interesting graph. That was a graph done by an independent test house some years ago for smartmicro, and it compared a loop with a known working loop with the radar in fairly hostile conditions in Finland. I think there was a light dusting of snow, and it's pretty cold, etc., etc., and it looks pretty good from what you can see there. That's what the product looks like. So again, on the right-hand side here, that's the SRO unit, which plugs onto the back of the radar and gives you 8 programmable outputs for interfacing to your traffic signal controller or to your MOVA unit, whatever you're doing. The radar itself has a stainless steel bracket. It's a pretty small unit. And it draws less than 5 watts. So it's a very energy efficient piece of kit. As I said, the range of that particular unit, 219 meters. We don't actually generally sell it like that because engineers working inside the SRO find it fairly difficult on site. So we tend to package it for our clients, and we package it like this at our workshop down in Hampshire before we ship to site. So we've added Wi-Fi to the unit. We've added the Copex there, umbilical. We've also put in a Phoenix connector in the junction box there to take your traffic signal cables into it, makes it easier to install on site. And we can also pre-program the radar before we ship it to your site as well. So it cuts down engineering time on site, makes the installation a lot easier and a lot neater for the engineer. In addition to that, we've developed a product called Novus. I've heard quite a few presentations about data collection this afternoon. We were fortunate enough to get a grant from Innovate UK, for which I thank them. And we took the data that the radar generates. In addition to doing all of the loop emulation, it's generating data. We take that data and we convert it into usable data. We collect it on our Novus unit. There's a 256 gigabyte hard drive on there. We can either store it locally on site or we can send it to your back office. We've developed our own back office recently with some colleagues, which we call Ipsum City. But we've also recently, I think, integrating into the Drakewell system. We're looking at also integrating it into some of the other commonly used back office systems in the traffic industry. Going back to the junction, we've got Novus on that junction for data collection as well. As Bob said, that's the junction. That is the junction dragged and dropped into our software. It's called the TMC software, Traffic Management Configurator. We can then position the radars electronically within the software and plot the in and out loops, the stop line, the advanced areas. And the one area that we did have some problems with, which Bob alluded to, was the one at the bottom there, which is the Northern Road, it's called. That had a bend in it. You can actually bend the lanes within the software, so the radar sees, if you like, curved roads. Clearly, you can't do it around a 90-degree bend, because if you can't see around the bend, then the radar can't see around the bend. But there we plotted the Northern Road. It has turned out to be a pretty good performance out of that radar. There are 4 of them on the junction, and so far they've worked extremely well. And I think, just to give you another idea on the installation, we tend to use the TRP 3-meter extension pole on our installations. That means we can install from a ladder generally, and we don't need a MUP. So actually, most of our installations include the TRP extension pole, and the one on the very left there has actually got 2 radars on it, again, because it's close to the controller, I think. So that's what an installation looks like. We tend to install between about 5 and 7 meters generally. So we can install the radar from ladders and then just simply push it up and align it and check it through the Wi-Fi with the laptop. Okay, I'll hand back over to Bob. I hope the computer doesn't pack in.
Yes, just quickly, because I've seen the red light on, just quickly summarising the performance. Generally, we've been very, very happy with the performance. It wasn't set up as a comparison for what went before and what comes now, or loops versus any overhead detector. It was basically a means to an end because we needed a new detection system. Cost-wise, we did look at a conventional loop system, even though that would reopen the issues with the bridge. And we were looking at £30,000 to £35,000. That's last year's money. That would probably be double now. Plus 2 or 3 weeks worth of disruption to the highway as you put in long lengths of ducting and cut in loops. This site was installed in 2 days. The first day was the pre-install with our engineers putting in the 12-core cable to the SVS detectors. The second day was the SVS engineer, Richard, came down, set it up within a day. So basically 2 days, and it was up and running. And the total cost there, as I say, was approximately £15,000 all in to equip the whole junction. The conclusions really, is again just reiterating the point that there was no comparison of what was there before and what is there now. Really, the only feedback we have is that we've had no complaints. That seems to be a running theme through all traffic signals works, that if no one complains, you take that as a plus. It just does what it's meant to do, and we are looking at implementing it at other sites. As Peter said, we have the Novus data capture unit as well, which our data collection people are looking at and investigating to see whether they can get any benefit from there. And as I say, we've just put our second site on behalf of an outside client last week, and hopefully, fingers crossed, that is still up and running. And I think that is the end. So thank you very much for your time.
I'll hold this up to my mouth if the battery was working, and you can envisage that the battery is working. So there's a gentleman here with a question. We'll have 2 questions, and then we'll have a coffee break.
What lessons have you learned by using it?
I would say it's been in for a year, and the lesson has been it has worked. It is something which we'd not seen before, so you have to be a bit brave to use a new contract. It wasn't from any of the established contractors or suppliers. And there was a bit of a leap of faith there because we'd seen the papers, we'd seen the presentations here, but there's still a leap of faith because it was new technology. But I think the lesson learned is, yes, it has worked. It is worth taking that punt. And as I say, even if it had failed, I know it's, to you and I, £15,000 is sort of a lot.
Spare parts, 'cause obviously that's...
At the moment, say, whenever there is an issue, so we're getting technical support from SVS. We are hoping to be able to, because we have our own maintenance capability, as we roll it out, as we get more sites, then hopefully we'll be able to maintain it ourselves, get spare parts in, so that if we do have issues, we can then carry it on.
Can I just add to that by saying we supply the software. Whoops. Thank you.
The stuff's breaking here, isn't it? We supply the software free of charge, so that's it. And we've also been supplying training as well. And we do hold stock of the radars directly from Germany. So. Yeah.
Okay, any other questions? Is that because coffee's beckoning? Oh.
Just a quick one. Are you, on the MOVA design and the validation, are you doing anything different because it's a radar system, or are you replicating what you would have done with loops?
As it stands, we have just replicated the loops. The whole exercise was, the loops were failing, or the detection was on its last legs. We had to get something else in, so it's been treated as a like for like. Maybe in the future, as we get more experience and we see how it behaves, that may be an avenue we need to have a look at. But at the moment, it's just like for like.
And the validation?
The
junction up differently?
The same. The junction has been left as it was prior to that under the old detection system at the moment. Obviously, we've had to make one or two tweaks because of that bend on the Northern Road approach, just to make sure that everything was visible and being able to see, so things were moved around slightly. But generally, it's a like-for-like replacement.
Okay, great. Well, a round of applause for all the speakers in that session. Thank you very, very much.